For example, vectors. So if you would like to understand the concept of the basis vector, so in two dimension case, so any point that is existed on x-axis, so it is having value of x and y 0 if the point is existed on the x-axis. If the point is existed on the y-axis, the point will be considering 0 and y. Okay, so that is the base of the vector, okay, along the x-axis, where the other part is 0. Here the y part is 0, here the x part is 0. Okay, so anything, for example, if something is written here, so it is having x value and y value. Okay, that will be another one, that is another vector, another point. Okay, so that's you could understand the basis vector. And it's very simple that in for example in vector, how you will add or how you will subtract the two vector. So for example, if you have vector u, which is having component u1, u2, u3, and you have v, which is v1, v2, v3, and if you would like to add u with v, so it will be u1 v1 comma u2 plus v2 comma u3 plus v3.
What does u mean?
U is basically the vectors which is having, for example, in 3 dimension, if you are writing a system of linear equation, so x is having some value, y is having some value, z is having some value. For example, your vector is something 3, 4, 5, so it's a 3-dimensional. Okay, this is u, and v is something, could be 1, -1, 5. Okay, and if you would like to add these two vector, so 3 plus 1,
u is
vector, u is also vector, v is also vector, and 4 minus 1, 5 minus 5, sorry, plus 5, 4 minus 1. So because we will write here 4 plus minus 1, so the answer is 4, 3 and 10. So that is u plus v. The point is that if you have two vector u and v, and by adding you will get a new vector. Okay, by adding these two vector you will get a new vector. You got the point?
Here.
Yeah. So vector is basically representing some sort of position in the Cartesian plane. Okay, so for example, I have in 2 dimension 2, 3. What is the meaning of 2, 3? 2 is basically a horizontal distance along x-axis and vertical distance along the y-axis. So that is representing one of the point, okay, for the vector.
It's like Euclidean distance.
Yeah. Okay, so similarly, if you could generate a new point, so these 2 points could be added, could be subtracted, or if this point could also be multiplied with a number as well. For example, if you multiply with 2, so this point will be scaled, and the point will be shifted somewhere. It could be shifted. So that is basically a next property where we could simply multiply a vector with any number, CV. So if we multiply a vector with a number, so for example, if you have v is equal to v1, v2, v3, I'm just considering 3 dimension. So you have a CV means CV1, CV2 and CV3. So C will be multiplied to all the element of that vector.
CV.
Yeah, C could be any number. C is any number,
No UV.
is any non-zero.
Why not U? C.
Yeah, it could also be C with U as well, CU as well, no problem. The point is that a vector could be multiplied to any number. CU2, CU3. Okay, and then there is a zero vector as well, and standard basis I told you already. So the properties we have, it is commutative property, associative property hold, and distributive property hold, and identity properties also hold. When you add 0 with any vector, so you will get V. Example with solution. So for example, you have been given two vector u and v, 2 minus 1 3, 1 4 minus 2, and if you would like to add u with v, so what is happening? 2 plus 1 minus 1 plus 4, 3 plus minus 2. So by solving we are getting 3 3 1. So that is the addition of the matrix, two vectors. That is the addition of two matrix. So by adding two vector we are getting a new vector, 3 3 1. Starting with u and v, you are getting a new vector. And similarly in example 3.2, you have again a vector u, v. So find u minus v. So u minus v is also a new vector. Okay, so you will be adding to the corresponding position. What is mean by corresponding position? Corresponding position, at first position 1 4, 2 with minus 1, minus 3 with 2. That is the corresponding position you will add or subtract. So when you are subtracting, the sign will be of course reversed. Okay, when you are subtracting. And similarly you have a vector v, and if you want to multiply with 2, so each element will be multiplied by 2. 2 multiplied by 3 is 6, 2 multiplied by minus 2 is minus 4, and 2 multiplied by 5 is 10. So you got this answer. Okay, so now you have u and v. So our objective is to find 3u minus 2v. So first of all you will find 3u, and then you will find 2v. So after having these two vectors, you will find 3u minus 2v. Okay, so you will generate first of all this vector and then this vector, and after that you subtract these two vectors. So we will find 3u minus 2v. Okay, and it is how it is solved in the following. So 3u, 3 multiplied by u, so we are getting 6 minus 6 12, 2v is 6, 2 minus 2, and then is subtracted and we got minus 3, minus 8 and 14. Okay, it's simple one. So determine w can be written as a linear combination of u and v. So the linear combination is basically the determine w 7 minus 4 2 can be written as a linear combination of u and v. So linear combination mean that let me tell you the idea of linear combination. So for example, you have a vector v and v1 and v2, and you wanted to write v1 and v2 as a linear combination of v. Okay, you have a vector v and you wanted to write v1 and v2 as a linear combination of v. Then you will introduce a non-zero coefficient c. Okay, let's say c1 v1, and then with vector 2 you will introduce a new coefficient, that is c2 v2 in term of. So that is the how we would write a linear combination. So now we could say that v1 and v2 is a linear combination of v if the value of c1 and c2, whatever the value we found, it will satisfy the v. Okay, that is how we write the linear combination. So currently our objective is not to find the value of c1 and c2. Basically, when we were talking about some sort of system, for example, we have let's say x, y and z, three vectors, and our objective is to write these three as a linear combination of some another variable, let's say v. So v could be written as c1 x plus c2 y plus c3 z. Okay, so in each of the case, x is a three-dimensional vector, could be any number a1, b1, c1. This is x. Y could be a2, b2, c2, and z could also be a3, b3 or c3, could be any number. So in that case, you are making some sort of vectors associated with each x and y, and you are writing c1 along with c2 and c3. So that is how we write the linear combinations. Okay. So it is here. So here they have introduced coefficient a and coefficient b. Okay, b is multiple of u, and a is multiple of u and b is multiple of v, so that it is equal to this one. So it means that if you will able to find the value of ab, so then of course you could put the value of a and b to get it equal to 7 minus 4 and 2.
I want to write which end.
Let me turn on the recording. So objective is to write w as a linear combination of u and v. So what you will do, you will write w with u plus v by introducing two of the coefficients. Okay, it could be ab, it could be c1, c2, it could be any coefficients. It is up to you. In the text, in the lecture note, they have mentioned ab, but it's not just ab. You could have any like c1, c2, ab, whatever you want. So these are the coefficient. Okay, if you could write w in this form, that is called the linear combination. Okay, so now we'll just put the values inside. Whatever the value of the w, whatever the value of the v, we'll put inside, and in the same equation we'll put all those values and then solve. Okay, So the W is 7 minus 4 and 2. 7 minus 4 and 2. U 1 2 minus 1.
3 minus 1.
1 2 minus 1.
Okay, V equals 3 minus 1, 2.
3 minus 1
2.
2. Okay, so we got these numbers. Now we simply put all these values here. 7 minus 4 2 is equal to A. U is 1 2 minus 1 plus B is B into 3 minus 1 and 2. Okay, so when a number is multiplied to vector, so the number will be multiplied to each of the element. So it means that A multiplied by 1 is A multiplied by 2 is 2A multiplied by minus 1 is minus A, and B multiplied by 3 is 3B, B multiplied by minus 1 is minus B, and B multiplied by 2 is 2B. Now we could see that vectors can be added. So A will be added with 3B. Very good. 2A will be added with minus B, and minus A will be added with 2B. Okay. Now we'll just compare the corresponding entries, because W is equal to this one. Now we'll compare the corresponding entry. What is mean by corresponding entry? At first position we have 7. At first position we have A plus 3B. So we would write 7 is equal to A plus 3B. For minus 4 it should be 2A minus B, and for 2 it is A minus A plus 2B. Now we'll try to solve, because two coefficients and two unknowns, basically 2 unknowns and 3 equations. So it can be solved very easily. So this is, let's consider this is equation A, this is equation B. So if equation B multiply by 2, so then what would happen? It will change to 4 is equal to minus 2A plus 4B. If equation B multiply by 2, so we'll get 4 minus 2A plus 4B, isn't it?
Yes.
So that is equation C. Now equation, I'm writing again equation A. Equation A again. So after writing equation A, we'll just add both of these equations. Okay, so this will be cancelled, so we have 3B equal to 0, so B is equal to 0. Is it the same? So we got B is equal to 18.
Go vamos.
Goes should be, from the first equation we got 7 minus 3B. Substitute into second equation by putting B is equal to 0 in A, equation A, we are getting A is equal to minus 2. Okay, so since we obtained these two values, Okay, now we will put these values into the here we will use these values in this part.
Okay, A equals 7.
Okay,
Now
so
A
by
equals 7.
hmm,
A equals 7. Now
a is equal to minus 2.
minus 2.
Minus 2. Okay, so by putting these values into this linear combination form, so if you are putting b is equal to 0, so this part will go away, this part will be going away because b is equal to 0 and a is minus 2. So you will have, you can see that we have 7 minus 4 2, 7 minus 4 2 equal to a, which is equal to minus 2 into 1 2 minus 1, 1 2 minus 1, and b is equal to 0, and this vector will be altogether 0. There is no need to write even this vector, okay, because when it will be multiplied by 0, so answer is 0. So it means that we are remaining with minus 2, minus 4, and minus plus 2 plus 2. So you can see that 7 minus 4 and 2. So it means that 7 is not equal to minus 2. 7, the first number is not equal to minus 2. It means that W cannot be written as a linear combination of u and v, because 7 is not equal to minus 2. That is the first element. It is not matching. Okay, minus 2 minus 4 is matching, 2 with 2 is matching, but 7 with minus 2 is not matching. So it means that W cannot be written as a linear combination of u and v. So if you have been given 2 points P and Q, and you would like to find a direction vector PQ, so Q comes next, and okay, whatever the PQ, so you would write Q minus P by this way. So for example, if I'm asking you to find QP, so then you should write P minus Q. Okay, for PQ, Q minus P, for QP it is P minus Q. So Q is 4 minus 1 and 5 minus 1 3 minus 2. By solving, 4 minus 1 3, minus 1 minus 3 minus 4, and 5 minus plus 7. So that is PQ. Okay, what about QP? QP will be 1 3 minus 2 minus Q, 4 minus 1 5. So 1 minus 4 minus 3 and plus 1 4, and minus 2 and minus 5 minus 7. Okay, so you could see that a comparison (3 minus 4 7) and minus 3 4 minus 7. So these two vectors are in opposite direction. PQ is going this way and QP going this way, opposite direction vector. Okay, opposite direction.
The arrow.
Hmm?
The arrow go left side.
Yeah, no. Arrow will be like this one.
That means
PQ
4
and
minus
QP.
1, 5 minus 1 and 3 minus 2.
Both having the reverse direction by this way. One will going by this way, another by this way.
But here in the equation,
Yeah.
it will be 3 minus 4, 7, minus 4 minus 1.
The question express the vector, this vector, as a linear combination of standard basis vector in R3. Standard basis vector in R3. So this is the question. I'm turning on the recording. So let's call again W is equal to 5 minus 2, 7. Okay, as a linear combination of standard basis vector. So we are calling standard basis vector E1, E2, E3. So standard basis vector in R3 will be 1, 0, 0, 0, 1, 0 and 0, 0, 1. So these are the standard basis vector in R3. So where you have three points. Now we would write W as a linear combination of C1, E1, C2, E2 and C3, E3. Okay, so 5 minus 2, 7 can be written as C1, 1, 0, 0, C2, 0, 1, 0 and C3 is 0, 0, 1. So that's how we have we could write the vector and the linear combination of as a standard basis vector, because this one is our standard basis vector.